Okay, more examples then of solving trig functions. So let's say we have the tangent of alpha equals 1, and we want to solve for alpha. This time we're going to try something different and do our answers in degrees. And it'll tell you in the book which to do, whether they want your answer in degrees or radians. If they don't say, do radians. Okay. Alright, what angle is tangent equal to 1? We talked about this earlier. I had you repeat it over and over and over. 45. Okay, so if we're giving the answer in radian or in degrees, it's 45 degrees, okay? But then where does that happen again in our circle? All students take calculus. So it's going to be positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, negative 1. But instead of pi this time, since we're doing degrees, I keep changing the mode on you. 180k is usually how you would do it when you're using a variable like that. So how come I didn't do 45 plus 360k and then 225 plus 360k? Why didn't I do it separately like I did with cosine? Because it would end up being this anyway, right? Because if you add 180 to 45, you get 225, which is your quadrant 4 angle. Because the whole reason that ends up being different than the cosine one, because remember with cosine, when we did this problem, we found quadrant 1 and then it was plus 2k pi, and we did quadrant 4 and it was plus 2k pi. So why didn't we separate it this time too? So like 45 plus 360k and 225 plus 360k. The reason we didn't do that is because the period for tangent is pi, or 180. And so it's going to repeat every 180. Whereas cosine, because the period is 360, is only going to repeat every 360 in those quadrants, right? They're not, if they were across from each other, it would work, but they never are with sine and cosine. They're always two next to each other with sine and cosine. So you have to list them separately like this. But for tangent and cotangent, you can just do it with 180 because they repeat every 180. Is that clear? Do you want to do another one? You want to do like a calculator one again? Let's do a calculator one. Negative, ooh, this one's ugly. Negative 1.34. Let's do in degrees again. And yeah, take it from there. So what did your calculator give you? Oh, sorry. You can use your iPods. You just turn it sideways. Type it in backwards.
Turn sideways and type it backwards.
Negative 53 degrees. Okay, so then could we do with that what we did to the above problem and say the answer therefore is negative 53 degrees plus 180k?
No.
Could we do that?
No.
We could. But typically, guess what? Typically, they really, really like your answer to be like positive between 0 and 360. So here's a better answer. We actually would want to use that as a reference angle. And remember how, so it's negative, so that gave us a quadrant 4 answer, and we talked about that in section 4.1. The calculator gave us a quadrant 4 answer because inverse tangent is quadrants 1 and 4. Right?
Yes.
However, for this purpose here, it's also going to be what quadrant? Quadrant 2. So you could just do a quadrant 2 angle where that's a 53 degree reference angle. So here's 180, here's 53. How do we find the angle to start with? Yep. So what would that be? 127? So 127 plus 180k is a better way of answering that question. Does that mean this one is wrong? No, unless they specifically say, I think sometimes in the instructions they say to make sure you use the smallest angle between 0 and 360. So that would apply if they told you to do it that way. Do you understand that those are the same answer though? Because if you add 180 to this, you get the same thing, and it just keeps repeating over and over. Okay. All right, let's get into a little bit more complicated type of problem. I realize